Okay, beta. So students, in last lecture you have studied the response of the system for different values of zeta, right? So when zeta is equal to, just a second, starting from under dam system. Now this is the over dam system when zeta is greater than 1. So you have observed the response of for this system. When zeta is greater than 1, the system we are calling as overdamped response. The response of this system is called as overdamped response. So you have to remember zeta is greater than 1. Now this is the equation for transfer function for process. What is input? Input is unit step input. Okay, and the C of S is output. Okay. Now according to equation for transfer function is the ratio of Laplace of output to the Laplace of input. So C of S divided by R of S is transfer function. So writing the equation for CS is equal to transfer function, this transfer function into input R of S. So into 1 by S. So your equation for output C of S is equal to this equation 1 by S into 9 divided by S square plus 9S plus 9. आता इथे काय केलंय मुलांना बघा आपण while solving this example, please concentrate over here. So this is your characteristics equation S square plus 9S plus 9. So I have taken root of this. So please find out in your notebook root of this equation S square plus 9S plus 9. काय येतात त्याचे रूट बघा बरं. Please find out the root. So you will get two roots. First one is S plus 7.
Minus 7.8 and minus 1.1.
Yes, exactly. So these two are, हे बघा, हे जे दोन आहेत ना, these are the roots of this characteristics equation. किंवा equation म्हणा फक्त ह्याचे roots find out करायचे. I'm explaining stepwise how to solve this example. Okay, when zeta is greater than 1. ठीक है? And this is overdamped response. So find out root of this equation S square plus 9S plus 9. You will get these two roots. आता कसे find out करणार तुम्ही? येते का तुम्हाला roots find out करता?
Yes, ma'am.
Okay, no problem. Very good. So all students, please find the root of this equation. Okay. These are the roots. S as it is, 9 constant as it is. So CS is equal to 9 divided by S into root of this equation. S plus 7.854. Bracket complete. Second root का है S plus 1.146. Bracket complete. Okay. आता काय करायचं आपल्याला? Now all these are denominator में जे काही लिहिलेलं आहे मुलांना, all these are poles. Okay. And whatever written at the numerator, these are zeros. आता न्यूमरेटर मध्ये एकही टर्म नाहीये related to S. So there is no any zeros. Okay. Now coming to denominator, how many S terms are there? 3. S plus this, S plus this. So you are going to equate this this term is equal to 0. So S is equal to 0. Second term is S plus 7.854 is equal to 0. Third term S plus 1.146 is equal to 0. So you get S is equal to minus 7.8. S is equal to minus 1.146. Okay. Now these two nothing but poles of your characteristics equation. Okay. Along with S is equal to 0. Okay. So S is equal to 0. S is equal to minus 7.854. S is equal to minus 1.146. These are two real poles and one is at 0. Okay, 2 poles, no zeros. You have plotted these poles on S plane and that is located at left half of S plane. Okay. So this is the response. These are the 2 poles. First pole, second pole, and one more pole at S is equal to 0. Okay. And as these poles are located at left half of S plane, okay, the S plane is looking like this. And if you want to take C, this is the C of S, okay? So you have to take inverse transform of this, inverse Laplace of this, okay? So how to take that? For that, you have to find, by partial fraction, you have to find out the coefficients, okay? Are you familiar with this?
Yes, ma'am.
Okay, thank you, Vita. Okay, just wait, admitting students. हाँ, मग partial fraction ही तुम्हाला काय येणार आहे? 3 constants येणार आहे, okay? So just put that 3 constants over here. So you will get C of S is equal to this equation is equal to K1, K2, K3 divided by some terms, that is nothing but S. Second term का SL S plus 7.8, third term का SL S plus 1.16. Now, taking Laplace inverse of that equation, you will get C of t, and that C of t I have shown over here. Now let me know what is value of K1, what is value of K2, and what is value of K3. You have to find. Yes, anybody got it? K1, K2, K3 by partial fraction.
मैम एक मिनट आपका.
हाँ. And we have drawn the response. So response, this is the response for second order systems. This response we are calling as overdamped response. बरोबर? काय म्हणतो आपण याला? Overdamped response. एकच मिनिट थांबा, आपल्याला K1, K2, K3 च्या व्हॅल्यू मिळतील by partial fraction. Ashish is doing the same thing. And this is nothing but location of your poles in S plane. Okay. Now, secondly, I have explained about underdamped response, right? For underdamped response, again, I have taken this transfer function. Underdamped response means zeta is less than 1 and greater than 0. Or you can say zeta is lying between 0 to 1, varying between 0 to 1. Okay, now this is the transfer function. 9 divided by s square plus 3s plus 9. Okay, C of S is output, R of S is input. What is input? Input is unit step input. So R of S is equal to 1 by S. Now writing the equation for C of S is equal to G of S into R of S. G of S is nothing but this equation into R of S is this. So you'll get C of S. You are supposed to write, students, C of S is equal to 1 by S into 9 divided by S square plus 3s plus 9. Again, you are having two poles, no 0. Okay. First pole is at S is equal to 0. Second pole is at, find out roots of this equation, characteristics equation. What is that equation? S square plus 3s plus 9. Time with that roots, find out kara. You will get two roots. As power is 2, S plus something, S plus something. But for this equation, you will get roots with j omega. Roots with j omega. Okay, two roots. So two poles are there. And one pole is at S is equal to 0. So by partial fraction again, you will get equation C of t is equal to K1 divided by S, K2 divided by first root, plus K3 divided by second root. Then find out the constants. Then after that, you have to take Laplace inverse of this equation C of S. You will get, after taking Laplace inverse, you will get C of t is equal to K1 plus e raised to the power minus 1.5t into bracket K2 cos of 2.598t plus K3 sine of 2.598t. Bracket complete. Now let me know the value of K1, K2, K3 by partial fraction. You have to solve it. Then these are the poles. आता बघा poles कसं आलाय ह्याचं इक्वेशन हे जे सॉल्व केले आपण हे इक्वेशन you will get two roots and that roots are lying at S is equal to S1 and S2. S is equal to minus 1.5 plus 2.598J. S2 काय आहे? minus 1.5 minus 2.598J. Okay, so we are having two complex poles. Okay, S1, S2 is equal to
Yes, ma'am.
this term. Two complex poles आले आपल्याला. Okay, आता ते कसे locate करणार आपण? So here you have plotted the poles. So this is S1. S1 is equal to minus 1.5. First pole is located at this point. With what value? With real part is equal to minus 1.5 and imaginary part is equal to plus 2.598. Okay, on positive j omega axis. So first pole is located over here in S plane. Second pole is located over here. The real part remains same, but imaginary part is having magnitude same, but in reverse direction. So minus 2.598 G. Second pole is located over here. So in this case, in underdamped response, poles are located. These two poles are located in the left half of S plane. Okay, and this is nothing but underdamped response. Now observe it carefully. Initially, when your system is overdamped, at that time there is no any overshoot, right? But here, when system is underdamped, बघा ना इथे overshoot आलं की नाही? आलंय ना overshoot. Again, transient is there. Then your system is trying to settle after this point. So this is the response of second order system, that is underdamped response. Got my point?
Yes, ma'am.
Okay. इथपर्यंत आपण बघितलं होतं, right? Yes? बरोबर
Yes,
ना?
ma'am.
हाँ. Now, in this lecture, you are going to observe the undamped response. Again, same system, but zeta is equal to 0. That is nothing but we are calling that system or response as undamped. So this is your undamped response. Is it visible now? Undamped response. Okay.
Yes, ma'am. It is visible.
Okay, beta. When zeta is equal to 0. Now this is the output. C of S is output. R of S is input. R of S is unit step input. Hence R of S is equal to 1 by S. Transfer function for process is given in this block. You can say this is the transfer function for process. So what is the equation for transfer function? G of S. This is G of S. This is R of S. This is C of S. Okay. So C of S, we are writing equation for C of S is equal to 1 by S into 9 divided by S square plus 9. Now what is the equation over here? S to power का है 2. So you are having two poles and there is no any zeros. Okay. Numerator मध्ये S term नाहीये म्हणून काय म्हणतोय आपण? There is no any zero. Zeros are not present. Whereas poles are present. Okay, how many poles? Two poles are present. S square plus 9 आहे म्हणून आपण काय म्हणतो? Two poles are present. But system response is undamped. For that, zeta is equal to 0. Zeta 0 असेल की काय असते system? Undamped असते. So let us see and locate the poles. You have to find out poles and you have to locate that poles on S plane. Okay, चला. काय करायचं आपल्याला? हे इक्वेशनचे रूट्स काढायचे. You will get two values of S1 and S2. Okay, so what is that two value? S square plus 9 is equal to 0. S square is equal to under root of 9.
Plus minus
Plus
J.
minus J3. अगदी बरोबर. So first pole at S is equal to 0. बरोबर? S is equal to 0. Second, S1, S2 is equal to plus minus J3. So you are having two imaginary poles. Now you are going to locate it. That is very simple. But coming to your this response C of T, how to get? You have to write equation for C of S first. C of S is equal to 1 by S into 9 divided by s square plus 9. After finding the roots of this equation s square plus 9, you will get poles, that is s1 s2 is equal to plus minus j3. Okay, these are 2 plus and minus 2 imaginary pole. Why imaginary? Because j term is included in this root. Okay, 3j. आता पहिला पोल कुठे असेल आपल्याला आपल्या एस प्लेन मध्ये ऍट प्लस j3
minus.
yes exactly very good Ashish, I like it, thank you beta. सेकंड पोल कुठे लोकेट होईल ऍट मायनस j3 ऑन इमॅजिनरी ऍक्सिस. इमॅजिनरी ऍक्सिस वरच आपले दोन्ही पण पोल आहेत. एक आहे पॉझिटिव्ह डायरेक्शनला, दुसरा आहे निगेटिव्ह डायरेक्शनला. दॅट आय एम गोइंग टू शो यू, बट लेट मी एक्सप्लेन अबाउट हाऊ टू सॉल्व दिस एक्झाम्पल. सी ऑफ एस चं इक्वेशन मिळालं तुम्हाला. सी ऑफ एस इज इक्वल टू 1 by s into 9 divided by s square plus 9. Okay. After finding the roots of this equation, you will get poles, okay, that you are going to locate. That is okay, but how to get this equation? आता c of s चे इक्वेशन तुमच्याकडे आहे बाय पार्शियल फ्रॅक्शन इक्वेशन. म्हणजेच काय, a डिवाइडेड बाय s बरोबर, b डिवाइडेड बाय दिस टर्म, c डिवाइडेड बाय मायनस j3 बरोबर ना. Now find out the value of a, b, c or k1, k2, k3. K3 is not there. You have to find out k1 and k2 only. So find out the values, constant value. Then put that value over here instead of k1 and k2. I have written this equation in terms of k1 and k2. You are going to find the values of k1 and k2. Okay. Then after that, next step, by taking Laplace inverse of this c of s, you will get c of t in time domain is equal to काय तुमची k1 ची व्हॅल्यू आली असेल फॉर एक्झाम्पल 0.9 प्लस k2 ची जी व्हॅल्यू आली असेल फॉर एक्झाम्पल 29 into cos of 3t. Now this is the output equation for output, that is c of t. This is the equation of output in time domain. Got my point?
Yes, ma'am.
Okay. Now plot the poles. Now, for undamped response, when zeta is equal to 0, your system is continuously oscillating. हे बघा, continuous oscillations आहेत. Again, negative, positive, and so on. It's continuously oscillating. Stable होती का system? नहीं. So this is not of our use. When zeta is equal to 0, system response is called as undamped response. Now this is undamped response. So you have simulated, okay, in the experiment number 3. In the experiment number 4, you have simulated this. Zeta is equal to 0, right? The same response is here in front of you. Okay. Now coming to S plane. So this is S plane. This is real axis. This is imaginary axis. Positive real axis, negative real axis. Just a second. This is positive real axis on this. This one is negative real axis. This is positive imaginary axis. This is negative imaginary axis, right? So our pole is at plus j omega. So my first pole is lying over here. First pole is located on imaginary axis because real term is not present. Real term is equal to 0. That 0 is here. So S1 is equal to plus J3 is here. My first pole is located at this point on imaginary axis. Okay. Then second pole is located over here at J omega is equal to, yes, J omega is equal to minus J3. So this is how you can locate your poles. हे कुठले poles झाले? Imaginary pole. 2 imaginary poles. बरोबर? When zeta is equal to 0, the system response is undamped response. Got my point?
Yes, ma'am.
Okay, Beta. Thank you. Now, moving forward, only one category is remaining. And what is that category? You have observed the response for overdamped system. You have observed the response for underdamped system. Third one I have explained just now, that is when zeta is equal to 0, undamped system. One more is remaining. Fourth one is critically damped response. At that time, zeta is equal to 1. Now let us see the response. Are you with me, students? Are you with me, students?
Yes, ma'am.
Yes, ma'am.
Okay, okay, beta. Okay, thank you. चला पुढचा. Give the heading critically damped system. At that time, zeta is equal to 1. Critically damped system. Give the heading critically damped. Critically damped system. Standard equation is b divided by s square plus as plus b. Now, critically damped system is zeta is equal to 1. Okay. Now, this is our system. Here a is equal to 6. 6. This is b. This is b. So, draw the diagram for critically damped system when zeta is equal to 1. So, this is nothing but transfer function equation for our process. R of s is input, C of s is output. Okay. Input is unit step input. That's why R of s is equal to 1 by s. So what is output? Equation for output. C of s is equal to, student, you are supposed to write. I have given all these steps. I have not written over here, but I have explained all these steps in between. In between C of s and C of t. So student, please write C of s is equal to R of s into G of s. What is R of s? 1 by s. G of s is into 9, 1 by
9
s.
upon s square.
Yes, exactly. 9 divided by s square plus 6s plus 9. झालं आपल्याला C of s मिळालं. Now find out equation of roots of this equation. You will get 2 roots. Power 2 आहे, s ची power 2 आहे, म्हणजेच किती roots मिळणार तुम्हाला? 2 roots. Okay. So find out roots of this equation. S square plus 6s plus 9. It's very simple actually. बरोबर ना? 3, 3,
Yes,
9,
ma'am. 3.
Yes, ma'am.
6. So s plus 3
Equal roots.
equal roots. बरोबर. So you are having equal roots. Now, next step, your equation becomes like this. C of s is equal to 1 by s into 9 divided by s square plus 6s plus 9 is equal to, next line, 1 by s plus 1 divided by s plus 3 plus, sorry, a किंवा b कसं पण घ्या किंवा k1 k2 k3 घ्या. Okay. So k1 तर झालं, k2 divided by s plus 3 plus k3 divided by s plus 3. So what we got? We got s is equal to minus 3. Again, s1 is equal to minus 3, s2 is equal to minus 3, and s is equal to 0. That is there available. Okay. So we are having 2 real poles and also equal poles. बरोबर? म्हणजे हे काय होणार आहे? ओव्हरलॅप होणार आहे ना. s is equal to minus 3 पहिला पोल लोकेट केला आपण, परत दुसरा पोल कुठे असणार आहे? s2 पण आपला minus 3 आहे. So second pole is also located at the same point, s is equal to minus 3. So we are having 2 real and equal poles, right? 2 poles but no zeros. Now coming to this equation. Equation काय आलंय बघा? C of s is equal to 1 by s plus किंवा k1 divided by s plus k2 divided by s plus 3 plus k3 divided by s plus 3. Find out the constant k1, k2, k3. ते तुम्ही फाइंड आउट करायचे बाय पार्शियल फ्रॅक्शन. आता काय करायचं आपल्याला? जे काही कॉन्स्टंट आले ते तिथे पुट केले तुम्ही पार्शियल फ्रॅक्शन नंतर. आता वी आर गोइंग टू टेक इनव्हर्स लॅपलास ऑफ दॅट इक्वेशन. So by taking inverse Laplace transform, you will get C of S चा inverse transform काय आहे? C of t. 1 by S, आता K1 ची जी काही व्हॅल्यू असेल, that value divided by S. 1 by S चा Laplace inverse काय आलाय? 1, right? So that 1 into this constant, जो काही आला असेल by partial fraction, that we are going to write over here. Plus constant by partial fraction, you are going to write over here. आता बघा दुसरी टर्म काय आहे? 1 divided by S plus 3. Laplace inverse
Yes,
of
ma'am.
1 divided by S plus 3 is e raised to the power
E raised to minus
plus.
3t.
Yes, exactly. Very good, very good. इथे प्लस असेल, S प्लस असेल तर minus 3t येणार. S मायनस असतं तर काय आलं असतं Laplace inverse? Plus 3.
Plus.
Very good, very good. Thank you बेटा. असं थोडंसं मुलांना माझ्यासोबत बोलत चला तुम्ही. I like it. Thank you very much. Plus K3 जो काही व्हॅल्यू आली असेल पार्शियल फ्रॅक्शन, that we are going to write over here. ओके. परत इथे काय आलंय बघा, 1 divided by S plus 3, बरोबर. आता ही सेकंड टाइम आली आहे ना टर्म, बरोबर.
Yes, ma'am.
आता इथे K3 च्या ह्याच्यामध्ये तुमचं काहीतरी S फॉर्म मध्ये जर आलं असेल तर काय येईल आपला Laplace inverse? t into e raised to the power minus 3t. कारण S plus 3 आहे. S plus 3 असेल तर इथे minus 3t. Got my point? So please.
Yes, ma'am.
Okay बेटा, please revise partial fraction, please revise inverse Laplace transform and Laplace transform. ठीक आहे. पहिली जी स्टेप आहे ती आहे आपली Laplace transform. नंतर आपण रूट्स काढतो आणि लोकेट करतो पोल्स. नंतरच्या स्टेप मध्ये आपण काय करतोय? बाय पार्शियल फ्रॅक्शन यू विल गेट कॉन्स्टंट्स, व्हॅल्यू ऑफ कॉन्स्टंट. आफ्टर दॅट नेक्स्ट स्टेप मध्ये काय करतो? Laplace inverse घेतो. देन यू विल गेट दिस इक्वेशन इन टाइम डोमेन. C of t is nothing but in time domain. C of S, Laplace transform, taking inverse of this, you will get C of t with this equation. Okay? Got my point?
Yes, ma'am.
Okay,
Yes,
beta.
ma'am.
Thank you students. आता मी प्लॉट करते. हा, आता आपण प्लॉट करूया. पोल्स, टू रियल अँड इक्वल पोल्स. क्रिटिकली डॅम्प्ड रिस्पॉन्स. बघा एस प्लेन आहे माझं, पॉझिटिव्ह रिअल ऍक्सिस, निगेटिव्ह रिअल ऍक्सिस, पॉझिटिव्ह इमॅजिनरी ऍक्सिस, निगेटिव्ह इमॅजिनरी ऍक्सिस. ओके. टू पोल्स इक्वल, रिअल अँड इक्वल. सो S is equal to -3. First pole S1 is equal to -3 located at this point. Second pole दिसावा म्हणून फक्त थोडं डायव्हर्ट केलंय. हा, ऍक्च्युली ते ओव्हरलॅप आहे. So S2 is equal to also -3. So two poles are located at same point. Okay, on real axis, negative real axis, in the left half of S plane. Got my point? When system is critically damped, having critically damped response. आता बघा critically damped response. हा बघा critically damped. When zeta is equal to 1. This is C of t is output on x-axis. Time is taken in seconds. So this is my response for zeta is equal to 1. We are calling that response as critically damped response. Got my point? The same
Yes,
you have observed, right? The same thing you have observed in the cycle, right? You got all these responses, right?
Yes, ma'am.
Now summary of this. Second order system responses. For आता जे काही तुम्हाला मी 4 कॅटेगरी सांगितल्यात ना मुलांनो, so summary of that 4 category is shown over here in this response. Okay, now this is the second order response when unit step input is applied at input side. Okay, to second order system. So this response we are calling as second order responses. Now on y-axis again I am repeating, output is taken C of t, on x-axis time is taken in seconds. Now this is the system response. हे बघा हा जो response आहे, this is system response. System is oscillating continuously. This response we are calling as undamped response when zeta is equal to 0. Second response, this one. System overshoot is decreased, okay, but oscillating somehow. So this response is nothing but your underdamped response, okay. Now coming to third one. So this response is zeta is equal to 1, it is critically damped. And this one is nothing but your zeta value is equal to 0. Overdamped nahi hai ye. This one is zeta is equal to 9. This one is critically damped. Okay, with zeta is equal to 1. This system is
1.
zeta is equal to 0. He overdamped ever ka. He overdamped system hai. He chukla इथे जरा. This system is overdamped. This system is critically damped. This one is underdamped. This one is underdamped. And this system is undamped. Got my point?
Yes, ma'am. Clear.
Okay. Now, summary of all 4 categories of zeta is in front of you. Baga. This is the system equation. This is the system equation, okay? A is system equation, right? Generalized form. So transfer function for any system or any process is generally expressed in this form, b divided by s square plus as plus beta, okay? So this is nothing but your g of s. This is r of s, input. C of s is output. Input is unit step input. So Laplace of unit step is 1 by s. Now, for overdamped system, I have taken this. Because he slide in the summary of all 4 categories of responses. Okay. So this is the overdamped system. This is GS, RS, CS. RS is unit step again. Poles are located in the left half of S plane, and these 2 are poles. System response is like this. And C of t, we got this equation for C of t after solving, after simplification further. Then coming to underdamped system. R of s is unit step input. G of s is this equation. CS, you have calculated CT. So poles, 2 poles are located again in the, you are having 2 imaginary and complex poles. Okay. So 2 poles are located in the left half of S plane again. Okay. And system response is like this. You will get your equation for CT is equal to this after simplification. Okay. So please try to get it. Actually, this is nothing but final answer for your equation. Right. Then coming to third one, that is undamped system. This is the equation for GS. RS is same unit step. CS, you are going to write equation for CS in terms of GS into RS. Simplify, solve. You will get 2 poles at equal value, 2 imaginary poles for undamped system. So poles, 2 poles are located on imaginary axis, okay, as shown over here. And this is the response of your system. And hence, C of t is equal to 1 minus cos 3t. Very simple. By taking inverse Laplace of C of s, you will get this equation. Then, 4th category is critically damped. So this is the equation for GS. RS is 1 by s. CS is equal to RS into GS. 2 planes equal. 2 real and equal planes, equal poles are located in the S plane, right? Over here at S is equal to, rho is equal to -3. And your system response is like this for critically damped system. And you will get, after taking inverse Laplace of C of s, you will get C of t is equal to 1 minus 3t e raised to the power minus 3t minus e raised to the power minus 3t. Okay. Now observe all the equations in time domain. Please write all these 4 categories. This is nothing but summary of your unit 2. Summary of unit 2 for 4 categories. 4 types of responses when zeta is equal to 1, when zeta is equal to 0, when zeta is greater than 1, when zeta is less than 1. Overdamped means zeta greater than 1. Underdamped means zeta is lying between 0 and 1 or less than 1. Undamped, zeta is equal to 0. Critically damped, zeta is equal to 1. Now, student, observe the equation C of t. Let me know what is your observation. Please observe this. बघा equation बघा C of t चा after taking inverse Laplace, always you have you are having this term. C of t is equal to 1 plus or minus. C of t is equal to 1 plus or minus. C of t is equal to 1 plus or minus. C of t is equal to 1 plus or minus. जे काही असेल इक्वेशन त्याप्रमाणे, right? So what is meaning of this 1 plus, 1 minus, 1 minus, 1 minus?
मॅम आर एस जे आहे ना ते 1/s आहे ना, सो एक टर्म सी ऑफ एस ही 1/s एक टर्म असणार आणि त्याचं इनवर्स लॅप्लास 1 येतं.
Very good, Ashish. Thank you. Very good answer. I'm happy. So see, from just observing this equation, you will come to know the applied input is unit step input, because unit step input u of t is equal to 1 for t is greater than 0, u of t is equal to 0 for t is less than 0, and hence you are having C of t is equal to 1 because applied input is unit step input. Got my point? Understood?
Yes, ma'am.
Okay,
Yes,
Vidya.
ma'am.
Thank you. Thank you very much for your feedback. Very good answer you have given. आता बघा, आता मी responses दाखवते. All should be here. Are you with me, students, up to this? Remaining
Yes, ma'am.
students? Okay. अरे आज एकच
Yes,
स्टुडंट
ma'am.
आहे का क्लासमध्ये? थँक्यू. वरद काय झालं बेटा? वैष्णवी, where are you?
कळालं.
कळालंय. बरं बरं, ठीक आहे. चला आता रिस्पॉन्सेस बघूया. So effect of different damping ratio or damping factor zeta. Just you have observed all these things while simulating, saving and executing our code in Scilab. Okay, the same response तिथनच कॉपी पेस्ट केलाय मी आणि इथे तुम्हाला दाखवण्यासाठी स्लाइड मध्ये टाकलाय बघा. So when zeta is equal to 0.1, your system response is like this, oscillating, maximum overshoot. When the value of zeta is increased from 0.1 to 0.2, overshoot is decreased. Overshoot is decreased. बरोबर? Then when the value of zeta is changing from 0.2 to 0.4, overshoot is decreased. इथे पण decrease झालाय overshoot, right? 0.4 पासून 0.7 ला आलाय. The system response is like this. अजून कमी झाला overshoot, बरोबर? And system is trying to settle down. Again, from 0.7 to 1, there is no any overshoot. लगेच system stable होती आहे, बरोबर? When zeta is equal to 1, just we have observed it. Okay, less than 1 काय असतं? हे बघा, हे जे रिस्पॉन्स आहे हे सगळे काय आहे? when zeta is varying between 0 to 1, बरोबर? At 1, when zeta is equal to 1, this is the response that you have derived the equation. When zeta is equal to 2, the system is directly settled down. There is no any overshoot, no any transient. Okay, so in this direction, the value of zeta is decreased, and hence the value of overshoot, percentage overshoot, is reduced. Okay, got my point? Any doubt up to this? No doubt?
No, ma'am, no doubt.
No doubt, ma'am.
No.
No doubt. Okay, thank you, Bharat. Thank you, Ashish. Vaishnavi, CR, Lokesh, Shravani. You are representing.
Yes, ma'am. Clear.
Clear. Okay. Chalo. Now this is for you from my side. ठीक है ना? Is the screen visible?
Yes, ma'am.
Please note
Yes,
down.
ma'am.
Yes, ma'am.
Please note down. Example number 4, 5, 6. Second order system. Now this is nothing but our outcome, right? So you have to do it. Describe the nature of the second order system response via the value of damping ratio for the system with transfer function. So transfer function equation is given. First one is g of s is equal to 12 divided by s square plus 8s plus 12. So omega n square is equal to 12. And zeta omega n is equal to 4, or you can say 2 zeta omega n is equal to 8. First of all, find out value of natural frequency omega n and zeta, then proceed further. Then next example is transfer function for second order system is given, that is g of s is equal to 16 divided by s square plus 8x plus 16. Here omega n square is equal to 16. Take root of that, you will get omega n 4. Okay, then 8 is equal to 2 zeta omega n. Find out the value of zeta. Third equation. Transfer function equation for second order system is given, that is g of s is equal to 20 divided by s square plus 8s plus 20. So omega n is equal to under root of 20 and 2 zeta omega n is equal to 8. So find out omega n and zeta and then proceed further. And you have to have the equation for, yes, C of t. C of t. Assume input is unit step input. Unit step input. Okay. So hey, example solve करायचे तुम्हाला, and this is nothing but assignment number 2. Solve these 3 numerical and you are going to scan and submit in the Google Classroom. Clear?
Yes, ma'am.
Okay. So please write these 3 equations, and with this unit 2 is completed. Small part is remaining, that is steady state error. Okay, it will take small time. So with this unit 2 is completed. Thank you, students. Any doubt?
No, ma'am.
Thank you. Understood?
मैम वो practical
Yes,
batches से related थोड़ा सा पूछना है,
एक
मतलब कैसे
Any doubt up to this? Any doubt, students?
No, ma'am.
Okay.
No,
thank you.
ma'am.
No.
Okay. So with this, unit 2 is completed. Only small part is remaining. So I will provide you the notes on Google Classroom. Okay. For steady state error. Huh? In next week, I will take you.
Lectures on Google Classroom.
Yes, please. थोड़ा सा मोठ्याने बोल बेटा.
Post these lectures on Google Classroom.
I have given all these lectures on Google Classroom.